Let's begin. Today's July 24th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 6 criteria cards and 6 verification cards. Let's go to turingmachine.info for the details. So in today's puzzle, we're using the following 6 criteria cards. Criteria card 7, 9, 11, 16, 19, and 21. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria cards D, E, and F. So criteria card A looks at our last digit, our circle digit, and the Turing machine will let us know if its value is an even digit or an odd digit. Criteria card B looks at the 3-digit solution and will let us know whether, the quantity of 3's in the solution. So should there be no 3's, a single 3, perhaps 2, maybe even all 3 are 3. Criteria card C will look at our first 2 digits, triangle and square, and compare them. So should the value of the triangle digit be less than square? Should they be equal, or should the triangle value be greater than square? Criteria card D will look at our 3-digit solution, and the Turing machine will let us know a little bit about the ratio of even to odds. So should there be more even than odds or less even than odds? Criteria card E again looks at our first 2 digits, triangle and square, but this time we'll add them up and compare the sum to 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F again looks at our 3-digit solution, but will let us know a little bit about its structure. Specifically, is there a pair in the solution, as in the example 131, or is there no pair? And in that case, there are 2 possibilities. One where all the digits are different, as in the example 134, or it could be that all digits are the same, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all 6 criteria cards. And we're going to begin with an initial proposal of 314. So the first thing I want to test is I want to find out a little bit about what circle has. Is it an even digit or is it an odd digit? So let's go ahead and test criteria card A. Okay, so in this case, the Turing machine does not approve of what I have. I did choose an even 4. It does not approve of the even digit. So in fact, it's telling me that circle is an odd digit. So let's go ahead and type up that in our notes for section A. That circle is an odd digit. And since it is odd, it can't be even, so I'll cross out 2 and 4. The next thing I'd like to do is I'd like to test criteria card D that will let us know a little bit about the ratio of even to odds. So let's go ahead and test criteria card D. Okay, so it approves of the proposal. Notice that in my proposal of 314, I do have 2 odds to a single even. So basically, in this case, it is agreeing that there should be less even than odds. So let's go ahead and type that up in our notes in section D, that even should be less than odd. And what that means is there are 2 possibilities. Either there are 2 odds and a single even, or potentially all 3 digits are odd. We just don't have that information. All we know right now is that circle is odd. So anything's possible. And next, let's finish this round by testing criteria card F. Okay, so in this case, the Turing Machine does not approve of my proposal. Again, I do have 3, 1, 4. They are all unique, meaning there are no pairs, but the Turing Machine does not approve of that. So what it's telling me is that indeed there is a pair of digits. So let's go ahead and type that up in our notes in section F. There is a pair of digits. So that means that at a minimum, now we know a little bit more, we'll have 2 paired up odds, and of course that third digit is either even or odd. Okay, so again, that does it for this round. We did complete our 3 Turing tests, and now we're going to go into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test the number of threes. So at this point, I think it's still pretty wide open. There could be no threes. There could be a single 3, or there could be a pair of 3s. But I guess the only exception is that there's no way there could be 3 3s. They all could not be all 3. And so that would limit we've already established that there is a pair. So what else? We did not test criteria card C or E, which are both have something to do with triangle and square. So it's interesting, yeah, there is that equal possibility, but I would think that let's see, if it's equal, yeah, I guess there are too many possibilities. The first 2 paired up would give us a sum that's less than 6. 3 and 3 would give us exactly 6, and of course pairing up the 4s or the 5s would be a sum that is greater than 6. So I don't think that necessarily is impossible. Well, I guess actually, if it is going to be paired up, it can be the evens. So that's interesting. We cannot pair up the evens. So let's see, but we can pair up the odds. So 1, 1, 3, 3, and 5, 5. We could do that. We do have a pair. I'm thinking, again, we can't have a pair of evens, so if you have a pair of odds, if they were to be equal, then 1, 1, or 5, 5 would be maybe ideal, because then you could say, oh yes, and there's also a 3 or not a 3, right? So it could be like 1, 1, 3 or 1, 1, 5, with there being a 3 or not. And similarly, it could be 5, 5, and it could be a 1, no 3, or yes, there is a 3. And of course, choosing the appropriate pair would fall to, well, is the sum less than 6, or is it greater than 6? I guess it wouldn't be equal to 6. No, not necessarily. I guess you could have something like 1, 5, 1. The pairs are 1. But let's see. Equal. I am somewhat intrigued by, again, criteria card D, where we do know there are more odds than evens. So what would compel it to be, all 3 odds versus just 2 odds? I guess you could also have, we know circle is odd. So if triangle and square are not equal, then obviously one is bigger than the other. And I'm not sure. Yeah, because again, we haven't really pinpointed, are there 2 or 3 odds? Somehow we have to, definitively decide that. And I'm trying to see, how could we? So if we have a single 3, that would indicate that the other 2 have to be odd. So I think I am going to say that, let's see, so the question is circle odd, is circle 3, or is perhaps either triangle or square to be 3? So let me go ahead and I'm going to do 5, 5, 3. So let's try that and see where that gets us. 5, 5, 3. Okay, and the reason I chose that is I want to test criteria card C because I'm hoping that the sum, or sorry, not the sum, but the triangle and square are actually equal. So let's test C. Okay, yes, fantastic. So they are equal. So let's go ahead and put that in our notes for section C. So triangle plus square. Sorry, wrong one. Triangle is equal to square. Oops, did not copy the square. So they are indeed equal. And as I mentioned, since they are equal, that means that they would have to be both odd. So let me go ahead and cross out the evens. And so yeah, we have an all odd solution. The first 2, so the question is, could the first 2 be 3s? We do have that sum, and it's possible, it could be 6. Well, the only way it could be 6 is if it is 3, 3, and I imagine that it won't be 6 because if we know that the first 2 are equal and the sum is equal to 6, there's only one way, and that would tell us how many 3s there were. So I'm going to say it's not equal to 6. So it's a 50-50 between less than 6 and greater than 6. And so I'm feeling confident of our solution here. So let's go ahead, let's see. Yeah, I think I need to test both B and E. I don't think I can deduce one with the other. Yeah, it's either the 3 is there or not. So let's go ahead and test criteria card E to find the sum. Okay, so the sum is not greater than 6 as I have it. So again, I'm thinking that I don't think the sum can be equal to 6 because that would let us know that there are indeed 2 3s. So I'm going to type it up as I'm going to deduce that the sum is actually going to be less than 6, which then would imply that triangle and square are 1. So triangle plus square is less than 6. And again, the reason I'm saying that is that because if I did know the sum was 6, I'd know that there were 2 3s, which would make this card irrelevant. So, so I'm just gonna, I won't be crossing out anything, but I'm deducing then that it's gonna be 1 1. And now, is there a 3 or not in order to choose circle? So let's go ahead and test criteria card B, and there isn't. So that means that the solution would be 115. Okay, and so B, I'll just type it up as there is no single 3-digit. Oops, I typed it in wrong. I should have put 115, not 155. 115, since we already established that yes, triangle and square are equal. Okay, so this looks good. Let's go to turingmachine.info to verify. So do we have a solution of 115? Fantastic. All right, so let's go back and see, did we beat the Turing machine? Well, I believe we did do 6 tests. We did all 6 criteria cards, so that's good. We'll at least tie. And so we did ADF first, and then the other 3 in the second round. So ADF. So we did ADF, and then in the second round we did B, C, E. And let me just double check really quick. It doesn't, yeah. The 2 middle ones were both correct, so D and C were correct. D and C, yep. Okay, so how do we do? Okay, so we beat it by 1 question. So that's good. Like I said, whenever you equal the number of Turing tests to the number of criteria cards, that's a good indication that, you know, at the very least you'll tie, but there's a potential to win. Well, what do you think of this puzzle? How did you solve it? Did you find anything interesting about how I approached it, or did you see some inefficiency, or did I miss something? Please share that in the comments. If you did like the video, please do give it a thumbs up. And if you don't want to miss out on any future videos, please make sure to hit subscribe so you'll be notified. Well, until next time, have a great one.